Hi there. This question was sent to me by a former student. Just wanted to go through this and demonstrate how I do this kind of problem. So it says express as a single log if possible and then simplify. So what I notice here on this, let me rewrite this. You've got 3/2 times the natural log of 4x to the 6th minus 4/5 times the natural log of 2y to the 10th. This one's tricky because you have these expressions inside. You know, you have 4x squared on the inside, and you're multiplying that. Now, when I see this, you're only raising the x to the 6th power, and here you're only raising, y to the 10th power. We can look at this a couple different ways. One of my first inclinations is to take our coefficients out here, the 3/2 and the 4/5, and turn those into exponents. But when I do that, we have to do the whole thing. So watch what I do here. I'm going to do natural log of 4x to the 6th, all of that raised to the 3/2 power. Okay, that whole quantity has to be raised to the 3/2 power, minus the natural log of the quantity 2y to the 10th, all of that raised to the 4/5 power. And what you can do here is, at this point on the inside, you can kind of simplify what's on the inside here. And so let's take a look at this. The natural log of, let's do this. I'm going to do 4 to the 3/2, all right, because since I'm multiplying these two things here, I got to raise each of them to the 3/2, times x to the 6th, that raised to the 3/2, okay? And then minus, same thing here, natural log of 2 to the 4/5 power, and then times the quantity y to the 10th, that raised to the 4/5 power. Okay, from here, you got some options. One thing I'm going to do, I'm going to simplify these parts here. These are a little bit easier to simplify than the other ones. So here I've got the natural log of 4 to the 3/2 times, this is going to become, when I take 6 and multiply it by 3/2, 6 times 3 is 18, divided by 2 is 9. So this is x to the 9th, and then minus the natural log of 2 to the 4/5, leave that there for now. And then this is going to be 10 times 4 is 40, divided by 5 is 8. So you get y to the 8th. And all I'm doing is multiplying these two numbers. When you get a power raised to a power, you can multiply. The next thing I want to do is evaluate the 4 to the 3/2 and 2 to the 4/5. This one we can simplify, and I'm going to put this into radicals. So this is going to become the square root of 4, that whole thing raised to the 3rd power times x to the 9th, minus the natural log of, this is going to be the 5th root of 2 to the 4th power, and then times y to the 8th. Now what you'll notice is that on this one, I'm taking the square root of 4 first, and then taking the cube root. And the reason why I'm doing that is because I can take the square root of 4, whereas I can't take the 5th root of 2. Okay, and so we'll see what we get here. But over here, we get the natural log of 2 to the 3rd times x to the 9th minus the natural log of the 5th root of 16 times y to the 8th, okay? From here, you then have the natural log of 8 times x to the 9th minus the natural log of the 5th root of 16 times y to the 8th. And we can't take the 5th root of 16. That's just not going to do anything for us. And so at this point, because we've simplified inside of our log as much as we can, let's write this as a single log. Because I'm subtracting logs, we can divide what's on the inside. All right, so I'm going to write this as a single log, the natural log of 8x to the 9th all over the 5th root of 16, y to the 8th. And I want to say that that's as far as we can go with this. I'm not exactly sure what the answer is. You could, in theory, simplify the radical down here and rationalize your denominator. So you could leave it like that, or let's rationalize that denominator here. So I've got 8x to the 9th over the 5th root of 16 times y to the 8th. If I multiply this by the 5th root of 2, all right, the 5th root of 2, the reason why I'm doing that is because when I do that, the 5th root of 16 times the 5th root of 2 is going to become, let's do this up here, 8 times the 5th root of 2 times x to the 9th over, when I multiply these two parts together, I'm going to get the 5th root of 32. And that's going to give me, that is something I can evaluate. 2 times 2, multiplying 2 by itself 5 times gives you 32. So you can take the 5th root of 32, and that's just going to give you 2. So now you have the natural log of 8 times the 5th root of 2 times x to the 9th over 2 times y to the 8th. At this point, now you can divide out the 8 and the 2. That's going to divide out to 4 over 1. So now you have the natural log of 4 times the 5th root of 2 times x to the 9th all over y to the 8th. And that is your answer if you were to rationalize your denominator. So yeah, this is tricky. I am showing a lot of steps. A lot of these you can kind of do. You can kind of skip a lot of these, but it just depends on your comfort level. So this is going to be your answer if you don't rationalize your denominator here. This is your answer if you do rationalize your denominator. So hopefully that helps. Know what I'm doing. I'm really pulling a lot of stuff together with your laws of exponents and things like that. So hopefully this helps. Let me know if it doesn't. We'll talk to you soon. Thanks. Bye.